everyone, welcome to our webinar. My name is Vlasta, and together with Golvan, we will share with you some of our experience with a small POC that we did in the domain of social media ingestion and building a knowledge using Neo4j database. So the brief overview. First, Golvan will walk you through the hurdles and pleasures of social media scraping. Specifically, we focused on Twitter and Instagram. Also, we scraped from the same date range, being it last weekend, also news articles. Then we will show a couple of machine learning algorithms that you can use mostly out of the box, mostly in open source libraries and tools. So actually, what the idea here is to share a way how you can build a knowledge graph without any deep knowledge of data engineering or data science, because a lot of stuff is already out there and it's pretty straightforward to start using it. So let's take it from the start. Golvan?
Yes. Hey guys. So thank you, Vlasta. I'll be, as he said, I'll be talking about the ingestion, and I'll begin talking about what we did with the data. So there are three platforms that we use for ingestion: news networks, Twitter, and Instagram. So I'll begin with the social media ingestion, and there are two general routes that you can go with this. You can go social media API or community-made library. And the community is amazing, and there are some amazing libraries out there. But there are some advantages to both. If you're going for stability, and if you're going for something that's going to follow the platform as it gets updated, the API is the way to go. But it has some limitations, of course, just like the community-made library. A big limitation on the community-made library is that you're dependent on either your knowledge of the language that the library is written into, or you're dependent on the development team behind. So both choices are very interesting. We went with community-made libraries. So we have two choices that are very interesting if you're trying to do this yourself. I'll begin with Twitter. This was a pretty easy choice. Twint, it's pretty popular. It does not use the Twitter API. None of what we did, as I said, does. So it has none of the limitations. It does have some limitations, especially over when you're trying to scrape over profiles or favorites, and you're going to get around 3,200 posts per run. But these limitations for our testing purposes were completely fine. And in fact, we're scraping with batches of 1,000 to 1,200 tweets. So as I said, there are different ways of scraping data. You can scrape through profile, through favorite, through hashtag, and this is what we used, because as you can probably tell, it's absolutely impossible to scrape the entire Twitter platform or Instagram platform. It would be optimistic at best to say that this is feasible. So we chose about 10 hashtags that we scraped information from, both for Twitter and Instagram. So back to Twint, there is no sign-in required, and it's very fast and easy to use. And I mean, very fast. So here, yes, there are two ways of ingesting data with Twint, either as a command. So this example right here is just getting followers and followees of an account, or as a Python library, which is what we use because we're trying to run back-to-back Instagram and Twitter ingestion. So speaking of which, for the Instagram ingestion, this is a bit more difficult. Instagram has very specific limitations, and we used Instaloader. So Instaloader, again, community made. It does not use the Instagram API, which has the account limitation. You're going to be limited to 20 accounts that you can get data from. But it has the number of queries that's defined by Instagram, and you can go over that. You're limited to 200 queries per hour. It's still very easy to use, and you can get a bunch of information. It just takes time because whereas Twitter is text-based, and you're going to have a lot of tweets. You're going to have some multimedia, but it's mostly tweets, mostly text. Instagram is always multimedia based. So you're going to have a minimum of one image. And so getting all of that information is time consuming. So as I said, you have a budget of 200 queries per hour. What you do with it is on you. So there are two ways of ingesting the data, either post per post, where you get a lot of information per post, or have kind of a batch of posts approach. So post per post, it's on the right. None of these use browser emulation because that would be too much processing power for not much. But if you're the person running these queries, this is what it would look like. Post per post is on the right, and you can get all the names of the people that liked the content itself, the account that published the content, all the comments, the name of the people who follow the account, and all of that stuff. But while this is great, everything that you're getting is one query. And your budget of 200 queries per hour goes way too fast for our use case, of course. If your use case is different, then that's fine. So where we have the latter approach, the left one, which is we have a bit less information, but it's still plenty for us to then analyze. So we have a location when available. We have all the multimedia, the caption, which contains hashtags and possible URLs, and the person that published this. The last, and keep in mind, everything that we're getting, of course, is public data. It does not require you to log in to get to see this data. This is all public. And then the last thing that we're scraping is news articles. And to do this in an efficient way, what we did was we used Twitter again with Twint. We scraped tweets from news network accounts. So all the big news networks like Yahoo News, CBN, things like this, they all have Twitter accounts that redirect you to their websites. So we scraped tweets from on the same time span that we had data for, and we extracted all of the article URLs, and then we scraped these articles, and everything was put into the database. So for a quick demo of the scraping and to show you how easy it is, I'm switching to screen. All right. Vlasta, is my screen okay?
Yes, I think so.
Okay, awesome. Just want to make sure. So searching this right here, this is the script. That's it for scraping. So very easy. We have the keyword that we want to scrape on. In this case, we have moon because we had also NASA hashtag and rocket. The number of posts that we're getting. Twint is running by batches of 20. So if we have 5 posts for Instagram, we're going to get 20 posts for Twitter. This is the very simple Twint setup where you just put what you want to fill. So like date, time, username, all of these things that you can get. This is the very simple instaloader command to get it and to get all the data. And then this is the Twint command to get the data. All of this, you don't even need it. This is for us for post-processing the JSONs because we wanted them in a special format. So we chose 5 just because we're not going to spend too much time on this. But if we run this, you're going to see that it will connect to Instagram. Now, I don't know how everything running at the same time with the screen capture is going to be handled. But once it's connected to Instagram, you're going to see that we're getting so for the hashtag, we're getting JSONs with information. We're getting location if available, all of the multimedia, and you're going to see very quickly the Twitter scraping, which is lightning fast. Actually, that's it. And now we have in our data, we have Instagram data, all the multimedia and everything. And Twitter, we just have JSONs that we can later parse and use. Twitter is very fast because we are not getting multimedia at all at this stage. If we want multimedia, that's because there is multimedia. And if there is, it'll be in this photos field right here. It'll be a list of links that we can then get data from. So going back to the slides right here. Then the question is, what do we do with all this data? So we have text that we can extract things from. We have keywords in the form of hashtags. All these hashtags are keywords. And we have all of these images. So of course, we're going to run image analysis. So once the slide load up and I can actually change the slide, I have a great quote that Vlasta shows that I can show you. All right, it says it's loading. But I can already talk about the way we did it. All right, great. Now I can change. The quote is, we do expect multimedia posts to become the predominant type of post on social media. Even the text that accompanies those posts is getting shorter and shorter. It becomes increasingly important for companies to be able to understand what's going on in those images. And we agree with this. We already have hashtags. We have things that we get from the captions and all the text from the news. We want information on these images. Now, entering the world of image analysis is fabulous, and there are many ways to do it. We have object detection and image classification. If you're going for object detection, which is going to be, you have an image and you want to say on this image, there is a bike, a car, and two people. This is going to be object detection. Image classification is at the image level, so saying this image is about this. We went with image classification, and again, there are many ways that you can go with it, and we went with EfficientNet for its efficiency. So the way it handles the number of parameters, they're greatly reduced, so the models are less complex. So that means faster training, faster classification once you run it, and it's even runnable on CPUs. And this is great if you've ever done any kind of image analysis. You will see that without GPU acceleration, it's a nightmare, and EfficientNet actually handles it pretty well. So a quick demo of the database that we have, and I'm jumping back to screen sharing, which means it's going to take maybe a while. This is our Neo4j instance. And you can see here we have a bunch of labels. If we take Instagram post, I'll try to show you the general model of information that we have. All of these things are, all of these nodes are Instagram posts. And if you expand here, I'll try to make that a bit bigger for you. This is great. We have a lot of data. So what exactly do we have? This post right here specified their location, was posted from. So we have location. This is going to be great also to link Instagram posts or Twitter posts or whatever for that matter by location. We extracted all the hashtags that can, of course, link everything together. We have all of these objects that are EfficientNet objects, objects that have been detected. And here we have annotated text, which Vlasta is going to tell you more about, and the author. So here is, so we also have the path to the multimedia. We have the text and the Google Maps of a link to that location, the cleaned text, and then the normal text. And to show you this, this is the original picture of the post. So we have this picture right here. It was a post with two pictures, and then this picture right here. And of course, EfficientNet is not perfect. So we're going to have results like soup bowl or pot pie, but we do have espresso, cup, coffee, and menu. And all of these are objects that are in the image that are detected by EfficientNet, and if they're detected in another post, these posts are going to be linked together. And that's just the beginning. Everything that contains, for example, the word coffee, you just have to do some very, very simple Neo4j post-processing to remove the hashtag and link to if there's this word in an article, or this word in a caption in a Twitter post, for example. So since we're starting on the power of this, I'll give back the microphone to Vlasta, and he can tell you all about the NLP and what we do after with all that data.
Okay, thank you, Gourvan. All right, so basically, once we ingest the data and run the image analysis, we can continue to leveraging the other information source we have, and that's the actual text in all the nodes that we ingested into Neo4j. So for that, we can use various natural language processing techniques. Where natural language processing, NLP, is a, generally speaking, set of machine learning tools that allow computers to process and perhaps in time to understand human language. Typically, it consists of many basic steps, be it sentence segmentation, tokenization, stripping the grammatical variations of the words, so-called dematization, part of speech tagging, universal dependencies, and so on and so on, up to more advanced and therefore also more interesting for us. So that's being it sentiment analysis, being it named entity recognition, or going even a bit fancier, using the named entity recognition together with entity relations extraction to actually distill knowledge directly from the text without any predefined database. We can go to topic classification, keyword extraction, document classification, summarization. There are so many options out there that can be used. We here at Graphware, we are developing a platform called Hume, and part of it is actually a set of open source NLP procedures that seamlessly integrate with Neo4j. So you can basically upload a couple of our plugins into Neo4j, and then you can use a lot of the natural language processing techniques out of the box, just calling cipher queries in Neo4j browser, for example. So to give you an example, typically at the beginning, we need to define a processing pipeline, so-called annotation pipeline. So here, the first query is calling a simple GA NLP processor add pipeline, where we define what we are doing. So be it a language, English, text processor. Here we use Stanford Core NLP, with which we have a lot of great experience, especially for the English language. It's maintained by the Stanford University, and they keep developing it, provide a lot of high quality out of the box models. You can define the processing steps, being the tokenization, named entity recognition, dependency parsing, sentiment analysis, for example. And once you do this, you can then run another simple query, which here we leverage the APOC procedures. And this in this part, we basically run the actual annotation. So here the procedure GA NLP annotate, you pass the text of the tweet in this case, you specify the pipeline name that you defined before, and you attach a new nodes, which through has annotated text relation, which serve as a sort of metadata node or a gateway into the result of the NLP process. Another thing you can do here is to run keyword extraction. So keywords or key phrases are, let's say, a subset of words that describe meaningfully the document that's being investigated. In our case, we have a very good experience with an algorithm called TextRank, which is a combination of NLP and PageRank, and provides high quality keywords and key phrases. It's completely unsupervised. There is no training required. It works out of the box. It's super fast. So there are many advantages like that that make it often quite top choice for us. Of course, there are also more advanced machine learning algorithms, but from our experience, beating the state of the art is very hard for them. So here, basically how it works is you take the text, you run the NLP, you break the text into a sort of co-occurrence graph. So here we had, for example, some kind of sentence like natural criteria of compatibility of systems of linear Diophantine equations, and so on and so on. The text continues. So you basically build this graph, you deploy a PageRank on it to get some centrality notion of which nodes each of these tokens are actually most important, often recurring in the document. And then if you adapt a couple more tweaks coming from the NLP, you can actually get state-of-the-art results on a wide range of domains that we tested it on so far. So yes, so the next slide shows the cipher procedure that you can run after uploading our plugins. So basically, in this case, we show here processing news nodes, which have the annotated text, which was extracted previously with the NLP analysis. Then you can call the procedure TextRank, pass the annotated text, specify some parameters, like, for example, use dependencies, which is very helpful settings for extracting key phrases. So not just, for example, space, but the whole phrase, space station. And that turned out to be very, very useful feature on top of the traditional TextRank that significantly helps in the analysis. And yeah, then you run it and you get results. So here I think is good time to start a demo. Okay, so okay, it's loading, right? Yes, awesome. So here I have a Neo4j browser. We run a simple query like match tweet, return 25 of them. So here you can see a couple of tweets. For example, I click on this one. Golvan already explained in his talk how this model, how this graph model here is. So for example, here you have hashtags like Black Girls Rock in this case, which was tagged in this specific tweet. You have here the text, some metadata for the tweet, some links, possible images linked to it, and here there is the annotated text. When I click on this one, so this is the result of the NLP analysis that we ran. So here there are two things. Here is a keyword extracted by the TextRank. So actually, sorry, this is another topic. This is from the topic classification, and here we see there is one sentence in the tweet. If we click on the sentence, we can see each sentence have many tags. The tags are somehow related. You have some metadata nodes here. We call it tag occurrence, which contains a lot of metadata information like position in the sentence and part of speech tags and so on. And we have here nodes, which we call tag nodes, that are shared among different documents, and they contain the lemmatized version of the words in the dataset. So yeah, here, for example, a name, Julia, you can see here name identity, person identified automatically by the NLP processing pipeline. All right, so now I prepared some simple queries to show, for example, here. Here we are matching tweets with connected to news through a keyword, for example, and we will print some basic statistics. So basically, keyword number of tweets that match this keyword and number of news articles, and this is sorted in the reverse order by the number of tweets. So, for example, here we see that the most frequent tweet is actually a climate change, which makes complete sense because one of the hashtags that Goldman used for scraping Twitter was actually a hashtag climate change. You can see here Hong Kong, which is a very hot topic lately for political reasons. You can see some space stuff. Some of our tags were hashtags were related to SpaceX and NASA and ESA. So also these things make sense. Here you can see, for example, Greta Thunberg reconstructed as a keyword automatically, which makes again absolute sense since a lot of tweets are climate change related. All right, so maybe I can also show a visualization. So here again, the same query, we match tweets with news. This time I will show some graph. It can be a bit big. So obvious next step could be to actually build some cool visualizations with external library like keylines, or if you prefer Kibana Elasticsearch, there are many possibilities of how to handle it, how to integrate everything, and visualize also the images, so you can actually see immediately, even in the visualization, what it looks like. But anyways, here we have the keyword climate change. It's the most frequent one. There are tweets attached to it, so those reconstructed automatically by the text streaming algorithm. And yeah, you can see like several other relations. So here we have another keyword. Okay, for example, young people. So that was in another set of tweets. As you can see here, there was reconstructed young people phrase as a relevant phrase in this specific tweet, and that makes actually complete sense, because together, like generally speaking, climate change tends to incite a lot younger people. So actually, the combination of two keywords, climate change and young people, is actually can be actually considered a pretty good definition of a topic of a bunch of keywords. So right, yeah, I mean, by running ingestion of a couple of different data sources and some basic open source NLP libraries, you can already get a pretty decent graph and pretty decent knowledge in your database. Of course, like there are also many other stuff, like you can see all the nodes that have been created so far from this, and among them there are like names of people, for example, that have been identified in the text, locations, or even mentions of money, percentage, and so on. So there is already a lot of out-of-the-box information present in the database. All right, so that could be it for the screen sharing for now. So let's pause it or stop maybe. Okay, so going back to slides. All right. So what could be the next step on our way to the knowledge? So let's consider knowledge enrichment. There are traditionally 2 or 3 different ways how to handle this. You can either leverage an external knowledge base, be it Wikidata, Concept.net5, Microsoft Concept Graph, Thomson Reuters for financial data, and so on and so on. You can use internal knowledge base that many companies do have, be it based on internal documents and a list of employees and transactions and whatever. Or you can go in the direction of an automated knowledge extraction. What we mean here is the entity relations extraction. Take, for example, this sentence. Rich eventually became a staff writer at LaFace Records, where he wrote songs and so on and so on. So when you read it as a human, you clearly see that Rich is an employee of LaFace Records. So wouldn't it be cool if we were able to train a model that's able to do that for you? So instead of you reading thousands of articles or tweets, or millions of tweets in that case, you can actually just deploy the model and start getting something in the database. And so, for example, here, Rich, employee of LaFace Records. And maybe you can also integrate it with the external database at the same time, so you can find out that LaFace Records is located in, I suppose, France. So this way you can keep adding stuff and keep building knowledge all in one place, in one central place, in this case, the let's say, slowly growing knowledge graph. There are different ways how to do the entity relations extraction. I won't go into details, but we tested a couple of approaches. For example, the LSTM networks or the neural networks, which are traditionally good with sequence learning tasks. But recently, there is a lot of research going on in the graph convolutional networks, for example. And we tested a couple of approaches, and it turned out that actually in the domains that we tested it, they quite nicely outperform the LSTMs. So what they basically do here is that they take the sentence, they leverage the universal dependencies. So for example, here you have a determinant, like D is a determinant of mutation. You have prepositions, you have like compounds, and so on. So they basically build a graph like this, turn it into adjacency matrix, and the model learns to attend to relevant substructures in the graph to optimize the learning phase, to find out what is the best way to classify into relations. So I believe the best approach is the demo again. Very briefly, I will show you the database if I manage to share the screen. So I'll do this. And, okay, here we go. Apparently, there's never enough testing beforehand. All right, so let's have a look at the Neo4j database, and I will show just a couple of results that we got from the entity relations extraction. So, for example, here what we do, we take tag 1, second tag, and relation among them being employee of. Let's see what happens. So you see, here we have organizations in the left column. This is NASA and people that were automatically identified as candidates of employees at NASA or ESA or Fox News or White House. So you see, this can be a potentially very powerful approach, because without reading a single article or a single tweet, I can already see something from the data set. Nobody did this for me. This was automatically extracted. I can also learn that, for example, for White House, there is Greta Thunberg working, right? So, well, I mean, it's machine learning. So after all, maybe this is a prediction of the future, right? One never knows. But the point here is, yes, it can be a very powerful technique using models for building knowledge graphs, but of course it can also introduce false positives, or it can miss some interesting patterns. But that's always the price to pay. There are a couple of more relations that we could do, but I see we are a little bit late on schedule, so I will skip to showing perhaps something with sentiment analysis. Very briefly, this is model which was used as it comes from Stanford Core NLP, pre-trained model. You can see here I'm basically matching keyword climate change with sentences which have positive, negative, very positive, very negative, neutral labels added to them by the model and by our plugins. And I'm interested basically, okay, I care about climate change, so what is out there happening in the social media? So, for example, Twitter. And yes, like for the positive sentences, I get something that looks sort of positive, I suppose. It is must read. Some knows that climate change is a hoax. Hard to say. It's the cleanest sustainable energy source available. Do what's right now. So, you know, it sort of works. Like generally speaking, the sentiment analysis can be a bit problematic. It's a very hard task because people are also tend to be also ironic. So actually, you need often a little bit kind of word knowledge to be able to recognize when it's actually a joke or when it's actually a sentiment or management seriously or ironically, and you can also have a look at some negative sentiments. So ignorance breeds contempt and so on and so on. So you see, the thing that we are trying to show here is that we can pretty easily build. All right, switching to slides. Yes, you can pretty easily build knowledge from carefully choosing this set of algorithms and databases.
10 minutes.
Okay, yeah, thank you. So just to wrap up, what we try to share here is the idea of a knowledge graph as one of the possible interpretation of knowledge graph as a connected knowledge, which comes from various kinds of sources and from many different sources and from even different databases. It can be all integrated in one database. It can even be built automatically using state-of-the-art machine learning algorithms. And it can be very powerful in helping to distill knowledge from a lot of information already present in many databases, but nobody really can read thousands of articles or thousands of books, or not to mention millions of tweets. It can be considered as a good basis for an intelligence platform. I mean, if you have questions like how is our product being perceived by the public, or what is the impact of a news article about our company, or how to extract knowledge spread across multiple data sources. So, I mean, in one article, I can learn that, person X is an employee of company B, and company B is, in another article, I can find out that company B is related in some way to company C, and so on. So the world is changing so fast that it's never possible to actually maintain a hard-coded knowledge base. It's actually a very good idea to move in the direction of using models to actually help to leverage all the information, all the possibilities that are out there. All right, thank you very much for attending our webinar. One last slide here are the Hunger Games questions. So
you see the tweet from Michael Simmons.
Easy one. What is harder to scrape, Twitter or Instagram? Medium. What was the library used for Twitter scraping? Tweak, Twitter loader, Twint. And the hard one, which machine learning model was used for entity relations extraction? Was it LSTM, GCN, GAN? All right.
Awesome. Thank you guys.
Adam Thornhill, software design.
Yeah, does anybody have any questions that want to ask? You can ask in the regular chat now or in the Q&A.
Using
Great job, by the way, guys. This is a really interesting project.
Thank you.
Thank you.
Very cool. Nobody has any questions? You can raise your hand if you have questions. There's a little hand icon next to the emoji thing in the message field. So I mean, are you guys looking at the chat? You guys have some feedback, people saying that they liked it. Roberto's asking about what the open source library was for NLP. If you want to
yeah, for NLP, well, we use very often Stanford Core NLP. It's a very good library that is out there with many pre-trained models. We also experimented with OpenNLP, for example, also a very good library that's easily integrable in the system. Yeah, I see also a question in the Q&A section. There is the last time I used graphical NLP, it wasn't the fastest. Is it possible to parallelize the process or something to speed it up? So yes, we have basically two, let's say, products. One of them, part of the product is open source, so that's what you can find on the GitLab and etc. That's completely free to use, free to experiment with. We are there to help people to optimize or use it, but of course it is an open source version, so it is not actually intended for real deployment. For that we have an enterprise version where we did a lot of work on the the optimization and on we did a lot of benchmarks and processed tens of millions of articles without any issues. So yes, I guess that's the answer to the question.
Anything else? Thank you for your feedback, by the way. All right, I think we're good, right?
Okay. Thanks everyone for coming.
Thank you very much.
Feel free to visit our company site, graphicware.com. We have a blog post area there, so you can find a lot of more details about knowledge graphs and NLP and machine learning and many other things, of course, not just this. So, okay, see you next time at some other conference or webinar. Thank you. Goodbye.
Bye-bye.